So I want to take just I don't know, however long it takes, and do a little bit of a language review. And so this isn't designed to teach you language, but just to reinforce and remind you of what you should already know. So if you're just getting started with Go, you should absolutely check out my Go programming course where I teach the language fundamentals and teach you how to program in Go. And I have to resist the urge just to teach you everything from the very beginning because I'm so used to doing that in a class. But I got to remember, you already know all this stuff because you've taken the Go programming fundamentals. But one of the things you really need to know is you really need to know interfaces and polymorphism and composition in Go and how all that works. So I'm just going to take whatever time this takes and do a little review of the language. And this is what we're going to cover: variables, data structures, functions, and composition. So that's that. You can just kind of tune in on that for a second and look at that. And that's what we're going to look at in this video. So you could skip ahead if you want to get down to this stuff. So the first thing to know is like variable declaration, and different people maybe have learned Go from different places. Maybe you got a book and you didn't learn it from me, God forbid. And so there's the short variable declaration operator. And so that is this, right? And you always want to use the short variable declaration operator when you can, and it's just more concise. And so that initializes a variable, declares and assigns it, and figures out the type for you. And it can only be used in a code block, right? So inside a code block like that, you couldn't use it outside the code block out here. And the scope of X is going to be from there down to here, right? And so if I had something up here, I couldn't call X. That's going to give me an error, but I can do it right there. So that's the short variable declaration operator, and you can see the type of that variable if I wanted to by just doing this and that, and printf %t will show me the type, and that is under print, you know, the verbs that you use to do that type of printing. And so if I ran that, go run main, I get everything's firing up int because it's an int. Okay, so that's a short variable declaration operator. You could also declare, you know, a variable out here, and you know, and then that has package level scope. So anywhere in this package, I'm able to access that variable X, and so that's package level scope versus block level scope. And so that's declaring a variable. And the var keyword is used to declare a variable and set it to a 0 value. So the value of X at that point right there would be 0 because the 0 value of an int is 0. So that's declaring with var or the short declaration operator. Cool, so that's variables and scope. And then we have data structures and composite literals. So you could go to the Golang spec or Effective Go and learn about a composite literal. And a composite literal is one of the most important things that you need to know when it comes to creating stuff. And a composite literal is going to be just basically the type, and then curly braces, and the data in between. So let me show you what that looks like. So if I have a slice of int, and I would say int, and I would say a slice of int, and then that, and then the numbers. Okay, and so that would be my slice of int, and I could do a funct println xi. There we go. And then I could do also, so that's a slice, and a slice is a data structure used for holding a list of things. There I'm holding a list of ints, but I could hold a list of anything. So the next one is a map, and I could do a map literal too. So my map is going to have a key and a value, and I just give it what I want it to be. So maybe string and int. So I'm going to store people's ages. And so again, notice the composite literal. I've got the type, and then I have curly braces, and then I populate it with values. So the key would be Todd, and the value would be 45, and then, I don't know, Job, my friend Job, and he's probably like 42. And when you list things out, like in one row, you do not need the trailing comma. You can have it if you want it. When you list things out like this, kind of going vertically, you need that trailing end comma, and there's reasons for that. And the reasons are basically it's just good code practice. And so I could print that out, and let's just run that to see Make sure I'm doing everything right. Go run main. There we go. And then the last composite literal, or the last data type. So maps are for key values and quick lookups by key. The last data structure to look at is a struct. So type person, struct, and then you give it field. So I'm defining that new type. Goes all about types. I'm creating my own types. I could create types. I could create a type hot dog where the underlying type is an int, and then I could say var, I don't know, t is a hot dog, t equals 7. I could do that. That's totally wacky. And it's cool, right? Tech is about innovation, yet even the innovators, the programmers, the people in tech get stuck in their ruts of doing it the way they always done it. And they're like, what? This isn't OOP. And then they freak out. It's like, you're an innovator. Innovate. So there's type person struct, and I put in fields. So f name string, l name string, and so this would be the equivalent of an object, right? Where we have fields. Object knows something and it does something, and so we could store data associated with the person, and then we could also attach a function to a person, and that becomes a method. And so that's fname, lname, and lowercase means that this is not visible outside the package. Uppercase, I'd need to make it uppercase if I wanted that field to be visible outside the package, but I'm not taking this outside the package, so I'm keeping it lower. So that's my person, and then if I need a person, I'm going to say p1 colon equal, composite literal is the type, and then the curly braces, and then the data values. And if I put them in order, I think that's just her first name. My microphone gets in the way here, by the way, of me seeing my code, so I have to zoom that up. So that if I give values to the fields in order, I do not need to provide the field name. Okay, so I could just populate the fields of that struct person like that. And then I could funct print line P1, and I could print out Miss Moneypenny. Miss Moneypenny, cool. All right, so that's composite literals, and there's the for range, which you should know. So if you don't know the for range loop, you need to go check out my other course. And next thing I'm going to show you, let's see what's next on the list. We did data structures, composite literals, and then we have functions and composition. So a function is going to be of this syntax: func keyword, receiver, identifier, parameters, returns, curly braces, and code. And so that's new for a lot of people, seeing this receiver thing out here, but that's how you attach a function of some identifier to a type. You use a receiver. But so if I wanted to attach a function to person, I could say func p person, and I could use any value I want here. This is just like another parameter or another argument that you could pass in. And then I could say speak, and it returns nothing, and then I could just have p dot func dot println p dot fname says, and I'll use backticks, says good morning, James. Just checking that out, make sure I said it all right. All right, so that's using fname from person, and that's that. And so now I could do p dot one speak. Miss says, good morning, James. I think I want to add in p fname, p lname. Miss Moneypenny says, good morning, James. I like it. So that's a function, and then that's also a method. And so let's say we wanted to do a little composition now, because now we're moving into this stuff. We did functions and methods. Now we're going to do composition, embedded types, interfaces, and polymorphism. So let's say I have another type, which is secret agent. And that's a struct. And secret agent is a person, and they also have a license to kill, which is a bool. And so if I create a secret agent, and I could get rid of my slice and my map. So if I create a secret agent 1 is equal to a secret agent. I'm going to use my composite literal, which is the type, and then the curly braces. And then I populate the fields, and the first field is this type, composite literal, right? And then the next field is going to be license to kill, and James Bond does have a license to kill. And so now I need to populate who that is, and that is James Bond. And then I could, if I wanted to, I'm going to come up here and I'm going to give James a secret agent method. And so I'm going to do SA sex. That's not what I wanted to write. Maybe it is what I wanted to write. Secret agent speak. And then I could do SAF name, SAL name says shaken, not stirred. You know, that's like, I just thought of that. That's like a good metaphor for James Bond just straight out of the gate, right? Like he goes through all these intense situations and he gets shaken up a little bit, but not stirred, baby. Not stirred. He's still cool. And so now I could have Secret Agent 1 speak. And run that. James Bond says, shaken, not stirred. Cool. So we've created new types, and we've attached functions, methods to those types, and we've embedded a type, and we have inner type promotion. So the embedded type, all those inner types, F name, L name, get promoted. We also have a conflict because a secret agent is a person and more, right? But James Bond's a person and more. Secret agent is a person and more. And so secret agent has the speak method and the person has a speak method. And so something that, you know, astute programmers, you know, or some programmers often ask themselves or ask me is like, well, you have a conflict. How do we know which one? And can we access the other? You can access the other. I could say I could do it that way, and I could also do it this way, right? James Bond says, shaken, not stirred. James Bond says, good morning, James. And so I could drill down to that inner type, and I could call fields or methods associated with that inner type by just scoping it with dot notation. Sweet. I've learned a few things over the last bit of time studying this language. So the last thing we're going to talk about are interfaces and polymorphism. So an interface is type. I'm going to create a new type again. And what type is it? It's an interface. And interfaces define functionality and allow polymorphism. So we could take two values of different types. And if they implement the interface, then they are also that type. You could be of more than one type, right? And so a person and a secret agent are both going to be a human. And they're going to be a human because to be a human, you have to be able to speak. And so this analogy breaks down at the accessibility disability level because people who can't speak are still humans in the real world. But this analogy, to be a human, you got to speak. All right, so type human interface, you have to have the speak method. Right? Well, a person has the speak method and a secret agent has the speak method. So both a person and a secret agent implement implicitly without any explicit declaration. They implicitly implement the human interface, which means they are also of type human. And so I could create a new func, and this func could be, you know, say something, and it could take a human. And then it could run h.speak, right? So it could run the speak method for that human. And then I could just come down here, and I could take that out, and take that out. And we have polymorphism. When we do, what did I say? Something, and P1, because P1 is a human. say something, and SA1, because SA1 is a human. And so now say something is going to get called. We passed a human in as an argument, right? And then H, for that human, call their speak method. Miss Moneypenny says, good morning, James. James Bond says, shaken, not stirred. Whoa. So that's really cool. And that's polymorphism. Morphism, changing. So like we have a function that can take in many different disparate types, right? And it could change based upon what it takes in. So that's composition in Go. And you absolutely have to have a pretty good grasp of interfaces and composition and polymorphism to understand the standard library and to understand web development with Go. So that's the beginning right here. And you can get to this file by going to 01 prereqs. And I thought I'd create a whole bunch of steps here, but I didn't. So I'm just going to delete that folder because that's no longer needed. And you could just review this and kind of like recode this several times. And I have a bunch of exercises to help you cement these things in. And so here are some hands-on exercises number 1. And I guess you could get to that document by going there. And these hands-on exercises are going to walk through what I just showed you and break things out in steps so you could see all that code I just wrote. And then here are the first hands-on exercises with solutions. So you can see the solutions. Solution, optional, additional info, not necessary, no assertions. So you can check that out too if you want. And then we also have hands-on exercise number 2. And these hands-on exercises will reinforce the language fundamentals and with all the solutions. So go through these. Make sure you go through these. If you're at all like not a solid Go programmer with the language fundamentals, make sure you go through all of these hands-on exercises. And then when you do it, use the playground, the Golang playground. And when you come up with a solution for those, say, hey, here's my solution at Todd McLeod, and tweet it. And I want to see your solutions just because it's kind of fun for me. I love seeing like what people are doing and feeling that community and being like, wow, look at all these students. And then people could drop in and they could see all that code under my Twitter account. So tweet at Todd McLeod and then also add on Golang snippet. And so under Twitter, right, you could do a Golang snippet search, pound Golang snippet as the hashtag. And you come up with these Golang snippets of little pieces of code. So do that when you do your solutions for those hands-on exercises. Tweet them with at Todd McLeod and hash Golang snippet, that little bit right there. Just add that to your tweet. Say, hey, here's one of my hands-on exercises, or here's composition, or here's the for range, or whatever, and add that to your tweet. That was fun. All right. I'm going to give you a little pep talk on how to succeed in the next video, and then we're going to start in learning about templates and doing web dev with Go.